Hello, welcome to our talk. In this talk, we will present PIEChain, a practical blockchain interoperability framework. Blockchains are distributed ledgers that track ownership of digital tokens such as cryptocurrencies. In particular, a blockchain contains a record of transactions in which digital tokens can be sent from one party to another. Different blockchains often do not interoperate by default, which means that it is non-trivial to guarantee that either all of the token transfers in a transaction happen, or none do. The goal of PIEChain is to enable secure transactions that involve different blockchains, without requiring changes to how these blockchains operate in isolation. PIEChain enables a variety of use cases, for example, auctions, loans, or insurance contracts that involve tokens on different blockchains. PIEChain uses the Kafka protocol for efficiency and usability, and its source code is publicly available. PIEChain is motivated by the emergence of a multitude of blockchain platforms that operate in silos. This ecosystem is dominated by the two largest platforms, Bitcoin and Ethereum, but there is a long tail of smaller platforms whose tokens are worth millions of dollars. As we can see from the table, the combined value of the smaller tokens accounts for a sizable fraction of the blockchain ecosystem's total value. There can be many reasons for a user to hold tokens on a smaller platform. For example, because its transaction costs are lower, or because it has built-in support for certain cryptographic operations. Examples of such emerging blockchain platforms include Cardano, Polygon, Solana, Polkadot, and Avalanche. Although users may hold tokens on different chains, there are cases in which they might want to interact. One prominent example is that of a cross-chain auction. In such an auction, an asset is sold on one blockchain. This can be a batch of cryptocurrencies, or a so-called non-fungible token that may represent anything from a concert ticket to the rights to an artwork. In this example, we consider a setting in which a ticket is sold on one chain, but bidders hold coins on several different chains. Since the ticket chain does not interoperate with the other blockchains by default, the question is how we can ensure that the winning bidder receives the ticket after having paid, or that the seller receives the correct payment after having transferred the ticket. To address this challenge, we propose PIEChain, a practical blockchain interoperability framework. The architecture of PIEChain is as follows. The most important agent type is the cross-chain service, which relays messages between users on different chains. These cross-chain services use the Kafka protocol to publish events, and users can subscribe to these events. In our auction example, both the seller and the bidders would subscribe to information about the bids that have been made. Another type of event is the conclusion of the auction, after which users who act as signers must indicate their support for committing the final transfer of the asset and the payment. The overall architecture of PIEChain is depicted in this slide. On top is the Kafka network, and below it are the published events reflect transactions on the blockchain. Finally, the users interact with the blockchain through transactions, for example by creating bids for the auction. A secure cross-chain transaction consists of 5 phases, which we will illustrate using the auction example. The first phase is the clearing phase, in which the cross-chain service creates the smart contracts that process the bids and the final transfer of assets and payments. The second phase is the escrow phase, in which all parties transfer their bids and the asset to the smart contract. The third phase is the transfer phase, which occurs after the auction is closed and during which the tentative exchange of tokens is sent to the contracts. In our case, this means that the asset is transferred to the winning bidder, and the winner's payment is transferred to the seller. The fourth phase is the validation phase, in which the signers verify that the proposed transfer is in accordance with the outcome of the auction. If so, they vote to commit. The fifth phase is the commitment phase, in which the exchange of the winning bid and asset are finalized, and the remaining bidders receive a refund. We will demonstrate a purpose-built graphical user interface for cross-chain auctions. Our demo consists of the following steps. First, we will refresh the view of existing auctions. Next, we will create sample auctions for non-fungible tokens. We will then use the interface in different windows to issue bids on multiple chains for the auction. Finally, we will conclude the auction and transfer the asset to the winning bidder, and the winner's payment to the seller. During all of these steps, we will use console windows to monitor the activity on the underlying blockchains. We have 5 auctions listed on the dashboard. Let's create a simple auction and verify all the required fields for this one. Next, we'll place a $150 bid using the auction contract deployed on Quorum. After that, we intentionally create an auction whose conclusion time has already passed. Compared to the previously generated auction, we notice that bids cannot be placed in an inactive auction. What will happen on both the front end and back end if we end an auction? We also notice that End Auction button is disabled. This time, we have 3 different users place bids on different platforms before the auction concludes. The first user, with an address ending in 3D3BF, places a $150 bid on the auction contract on Ethereum. The second user, with an address ending in 7EBFE, places a $50 bid on Quorum. The last user, with an address ending in ADFF, places a $100 bid on Quorum. After refreshing the page, we now have a total of 3 bids placed by 3 different users on Ethereum and Quorum. Let's wait until the conclusion time and check if the cross-chain auction ends as expected. In the end, let's press the End Auction button to check if the system correctly handles this cross-chain auction. As shown in the terminal below, the new asset owner placed the highest bid of $150 on Ethereum. Check one more time to see if we can end this auction again. In contrast, users can still place bids on active auctions. We also have other cool features like show real time on the page and reset all auctions.